Alright, so my name's Jens, and today we're going to be going over just exactly how to use artillery, such as this gun here, provided that you do not have access to the Fire Direction Control tablet, the FDC tablet. If you have the FDC tablet, then all you need is a 10-digit grid, and your 10-digit grid, and you can just plug and play. It'll spit out numbers, and you're going to have a great time just punching digits into the gun and letting her rip. But sometimes you don't have that. Maybe you just have a micro dagger. Maybe you just have map tools, and you still have to bring those fire missions down range. So that's what we're gonna do here today, and we're gonna start with this left us present here on the map, left the markers on, just to kind of simplify things a bit. And let's say that we want to hit TRP 1 up here. Let's say that our forward observer has not given us a 10-digit grid. They haven't given us a anything really we could plug into the tablet to work with, which is just fine because they're going to be presuming we don't have a tablet anyway. Well, first things first, we need to establish our position. So, thankfully, since we're in the Eden editor, we already have our position marked as this. However, we need to get the position of TRP1, which is going to be off up there somewhere, and figure out how far away it is, what angular displacement it is, and what the change in height between us and it is. So there's one very easy way to do that. You should have available to you something called a micro dagger. So the way the micro dagger works is it will display in 5-digit grid segments, 10-digit grid, right? Your easting, your northing, and your height above sea level. So a neat little trick we can do here is we can go over to the map and we can just scroll out, zoom in here on TRP1, which is this little tiny nubbin hilltop. Double click on it, name it TRP1 for record keeping purposes. And what we can do then is we can click Set Waypoint. And what that does is it gives us a heading, a range, and if we bump on over here, it'll give us how tall the target is as well. However, you're going to run into your first difficulty here. These digits are in degrees. What we need is milliradians. All of our adjustments, all of our gun settings are going to be in milliradians, right? So what we're going to do instead is we're going to bump on up to this little 4 cell service bars up here. We're going to go to settings, and we're going to just click on this, and it'll bump it over to mils. Now we can go back, and we can see, yes, we've got nice, happy information right here. So this would be the first way to obtain your 3 values of concern, because you're going to need an azimuth, you're going to need a range, and you're going to need an elevation. The other way to do it, if you don't have something handy like a micro dagger, you can go to the map, you can hold left control and right click on your person, and this little menu should pop up. What you can do is click distance, and you can just mouse on over, and you should be able to see the range of the target. We have 1693-ish. You can then right click to drop that. You can also go back to yourself, control right click, compass, and zoom in and get the heading as well. We get 6212, 6211, something like that. Close enough, right? And another thing you can do obviously is right click height, go over here, and bam, wouldn't you know it, you can see the target's height, and you can come over here and you can see your height. Well, the micro dagger is blocking you right now, but you would be able to see your height. At any rate, once you've obtained the target's height, your height, and the azimuth and range, we can proceed to the range table. So we have down here in the bottom right hand corner on our micro dagger, which should still be up, right? We've got our target elevation, our elevation, azimuth to target, range to target. So we're going to go to equipment. We're going to go to our range table, which is always going to be this weird Excel sheet looking thing here. It's going to have the name of whatever gun you're closest to on it. We're going to open that up, and we're going to pick a table to use. So we know that our target is 1.692 kilometers away. That means he's 1,692 meters away, right? So, since there is a bit of a change in elevation and there might be trees in the way, and also just because it's a little more fun this way because it's a little more indirect, we're going to pick a high firing arc. We have a high tab and a low tab. You'll notice that for the same ranges, like say 900, on the high tab we have a significantly increased elevation value. That's because it's lobbing the shells up like a foosball and then they come back down. Whereas low is more like, pitching a baseball. It's going to go whah and then slap down somewhere. When possible, you're going to prefer low angle fire missions as long as terrain features or features near the target such as houses or structures or trees will not block the incoming round. So, if we go over here, we can see that we have 1692 for our range, right? And we've got 1650, and we've got 1700. Could we fudge it and just say 1700? Yes, but that's bad practice. So what we're going to do instead is we're going to have to figure out where exactly in between these 2 points that are listed on the table our 1692 actually fits. So there's a very easy way to do this. If we just bump over here. All right, so the way this is going to work is we're going to have we're going to need to get our 2 ranges that are on the table, right? So if you go back, rewind a little bit, and look at the ones I was mousing around on, you'll see we had 1650 and we had 1700. Those are the actual tabulated ranges, and what we need to find that lies somewhere between them, right, is we need to find 1692. Okay, so we've established this. Now what we need to do next is take these values and perform a little operation with them called interpolation. So this is fairly simple. All we have to do is take our the range we want, which in this case is 1692. That's the range we want to hit at, right? And we're going to subtract from it the lower range from these 2 that kind of surround the range we're actually trying to hit at. So you're going to subtract that lower range of 1650, and then you're going to divide this entire value by the difference between these 2 ranges. So 1700 minus 1650. And this value should come out, if we whip out our handy TI-83, we've got what? I have 1692 minus 1650 over 1700, not the cosine of it, you dingus, over 1700 minus 1650, and we get, it's kind of hard to see because my camera doesn't like to focus at close distances, but we have 0.84. So let's go ahead and write that down, 0.84. And what you can think of this value as is it's the fraction, if we treat 1 as unity and 0 as null. This is the fraction of the way we are between those 2 values on the table. We are 84% of the distance from 1650 to 1700, right? So we'll take this value, and now what we need to do, now we figured out the range differences, we need to apply this fraction to the difference in our elevations. So going back to ARMA, we can see that our elevations are set at, where we got them? Okay, we've got 1217 and 1200. All right, so let's just go ahead and write those down. 1217 for 1650 and 1202 for 1700. All right, so now we can bump on back to Khan Academy And what we can do with these are our elevation values over here, right? So what we can do is we can take that 0.84 that we got earlier, and we can multiply it by the difference between the higher range elevation here minus the lower range elevation. So 0.84 times 1202 minus 1217. And something you're going to have to be careful of here is making sure that you're doing the elevation value for the further distance, the higher range, right, minus the elevation value for the lower range, because that's going to change based on what firing solution you're using. For example, if you're using a high angle, this number here is always going to be negative. However, if you're using a low angle shot, this number is always going to be positive. So we have 0.84 times 1202 minus 1217, and if we punch that into our handy dandy TI-83, we get 1202 minus 1217, 1217, and that gives us negative 12.6. Now what we can do then is take this number here, this negative 12.6, and we can add it to the lower elevation value here. So you see what we've done is we've basically multiplied the difference between the ranges as a percentage value, right, across this span of 1650 to 1700. And we're multiplying it by the span between our elevations on the range card in order to obtain the difference between the lower range card value, this 1217, and what we're actually going to need. So now we just take 1217 and add to it that negative 12.6, and that gives us 1204.4. So you think to yourself, wow, I'm a fucking genius. I've done it. I've cured cancer. I've done the artillery solution. Well, you're almost there. There's one final step we have to take into account. So if we go back to ARMA for just a second, we can see that we have a column right here that says D elevation per 100 meter drop. So that D up there stands for deviation. So for instance, at 1700 meters, if the target were 100 meters below my elevation, I would have to change my firing solution by 11 mils. I'd have to add 11 mils to whatever it is for every 100 meters below me the target was. So what we have to do here is figure out, well, how high or low is the target relative to us? So we can see the target's at 277 above sea level, and we can see that we're at 121 above sea level. So if you just take that difference of 277 minus 121, we can see that the target is going to be 156 meters above us. So keep that value in mind. Write that down. We've got 156 meters above us. Now what we can do with that value is we can take it, we can pair it with the value in this column. So for both ranges spanning the one we care about, right, we were looking for 1692, which is between 1650 and 1700. We see that the value here stays at 11. So we can just approximate it and say 11 is going to be our adjustment coefficient, right? So now that we've got that 11 in mind, what we can do, all right, so there's a fairly simple way to think of this. We've got, we have to add 11 mils for every 100 meters we drop, right? That's kind of how you can think of that table. So if we go ahead and turn this into, if we divide this by 100, then we can think of it as for every 1 meter we drop, we add 0.11 mils, right? Because if it's 11 mils per 100 meters, then divide that by 100, that means that it's 0.11 mils for every meter it goes down. So now we run into our second problem. the value on the table, that 11, which we've turned into 0.11, is for a decrease in elevation. The target is actually above us. It is above us by 156 meters, upward. So what we have to do is we have to take this value and actually make it negative because we're going in the opposite direction, right? It stands to reason that if we subtract or if we add that many mils for every 100 meters it drops, then we should be subtracting that many mils for however many 100 meters it rises. So what we're going to do is we're going to take this 1204.4 that we got earlier, and we are going to add to it the product of that negative 0.11 times our height difference. He is 156 meters above us. And this number is going to be our final firing solution, which plugged into the TI-83. Go ahead and multiply that by negative 0.11 plus 1204.4 gives us a final firing solution of 1187.24 mils, which we'll just go ahead and round down to 1187 mils. All right, so we've got our elevation figured out now from the values there. We also, if we go back to ARMA, can see that we have our azimuth. We have our azimuth, we have our elevation. That's all we need. So go ahead and write down the azimuth from your micro dagger right here, that 6211 value. Go ahead and write down your elevation value that we figured earlier, which is 1187 mils. And go ahead and write down your charge value, which you can see right now, this highlight here, right there. We are on charge 0 for a high angle shot. So write down that you're on charge 0, and if you want, for radio discipline, letting people know what you're up to, go ahead and write down the time of flight too. It's going to be about 29 seconds. People don't care about the decimals so much, so 29 seconds. And the way I like to do this as just kind of a general note-keeping thing is I will actually basically draw out a little sheet in a notebook, which I will show you now with the general formatting of azimuth, change in elevation, and range, which are the values we get from the micro dagger initially, right? We can determine from the micro dagger our heading to the target, how much taller or lower the target is than us, and the range to the target. And from these three values, we can determine everything else here through all the math on this page that we did before. So we've got 1187 for elevation. We've got 6211. So let's just go ahead back into ARMA and climb into the gun. Gunner seat. All right, so we're going to go ahead and set our azimuth, and you are going to want to be on relatively low sensitivity when you do this, because otherwise you are going to have overshoots and bad times, and it's just going to be generally unpleasant, I'm telling you right now. I say it was 6211. All right, and if we go ahead and bump on up with the elevation on the gun, you can see that we're already on semi-close, which is charge 0 for this gun. So we're just going to go ahead and crank it up to 1187. Please note that azimuth is adjusted. Azimuth, these are left to right. Yeah. Azimuth is adjusted just with the mouse or with your aiming hotkeys. Elevation has to be adjusted with page up or page down for large adjustments, and then to do fine tuning, you're going to use shift page up, page down. So we've got one round on TRP1. We'll go ahead and once we get the clear from Phantom, which there is no Phantom right now, right? We don't have a forward observer. We're just doing this ourselves for tits and pickles. Let's go ahead and fire. And then we will wait for the show. And do keep in mind it's going to take a hot minute for it to get there because it's a high angle firing solution. And we wait, and we wait, and we wait. And look at that. That's pretty damn close. Good job. You did it. So that's the general gist of artillery. Now, let's say that they call in and they tell you, oh, that was 50 meters off. Like, say that, they tell us, oh man, you were 50 meters off to the west of the TRP for whatever, right? Or say their TRP mark was bad and they actually meant for you to hit 50 meters off over here somewhere. Well, quick and dirty way we can do it is we can use the worm rule, right? We can take a little equation called W over M equals R, which is width over meters equals range, basically. And we can turn that into an adjustment. So since we're more or less south of this guy, we can just go ahead and divide. We can do, flipping back over to our scratch page here, we can just do something called W over M equals R. And so they tell us, okay, it has to go 50 meters east, right? All right, well, east for us is right on the azimuth, right? The azimuth has to go right to go east. So we have a distance of 50 meters divided by the adjustment in mil irradians is going to be equal to 1.692 km. So we have these two values. We need to get the mils down here. How do we do that? Well, we just take 50 over 1.692, and that's going to equal how many mils we have to adjust, which in our case, going back to the TI-83, 50 over 1.692, we have to adjust by right about 30 mils. So we have to move 30 mils to drag the shot over by 50 yards. So, going back to the game, Phantom's shouting at us. They've told us, oh, you need to adjust fire, you suck. All this fun, nasty things. So we started out on 6211, right? That was our initial heading. So we have to add 30 to that. So that would be 6411, right? 6241. So 6241, still on the same elevation, and we'll fire again. And we wait for it, and wait for it. And we did pretty good. Like, if you look at where that splash was and we adjust back over to sensor on it, we'll see that, yeah, that landed about on our initial heading. The gun shifted because we're in a SPG, and that's just going to be a fact of life whenever you're on something like a Paladin or a 109 or whatever. But generally speaking, we can adjust our fire missions pretty easily this way. So just keep in mind what you've learned here today. I have been Jens. It has been a pleasure teaching you. And I wish you nothing but the best in your artillery adventures.